let's graph the linear inequality in the plane. This says y is less than or equal to negative 1/3 times x plus 1. The first thing we want to do is remember to graph the associated line with this inequality. It is in y equals mx plus b form, where m is the slope. So it says negative 1 over 3. That could be interpreted as if you have an ordered pair on a line, from that ordered pair you're going to go down 1 and then right 3. Now we also know the y-intercept, and if you translate the y-intercept to an ordered pair, you'd know that this translates to 0, 1. So the first thing we're going to do is draw your set of axes. Do the best you can. You want to first plot the y-intercept. And the y-intercept is 0, 1. The slope says go down 1 and then right 3. I'm going to put 3 marks this way. And we get another dot here. And if you have a ruler, take advantage of a straight edge or a ruler and plot a straight line. And so you have a straight line there that goes through those two ordered pairs. And it is a solid line, and the way you know that, it says less than or equal to. The equal means you could actually shade this line. Now, we want to shade the true side of an inequality. So we're going to take the original inequality and choose a test point that is not on the line. Let's take the original inequality. And choose a test point that's not on the line. So why don't we pick on the origin here? Why don't we test the origin and see if we are able to shade it. So 0 is less than or equal to negative 1/3 times 0 plus 1. We want to know if this statement is true or false. 0 is less than or equal to 1. This is true. And what that means is 0, 0 is lying on the true side. 0, 0 is right here. We are actually going to shade 0, 0. In fact, you're not only going to shade 0, 0, you're going to shade negative 99, 0 as well, because it lies on the same side of the line that is going to represent a true inequality. So you only need to test 0, 0. You only need 1. If you test, you could easily test what? 0, negative 3. If you test 0, negative 3, it's going to work as well. It's going to give you a true statement. So we always shade all the true statements. In this case, we shade the 0, 0 side. So let's shade. We can also shade this line because it's equal to. So I could paint this line as well and shade that line. And now you shaded the entire solution set. So the answer to this problem is actually a graph. When you do this kind of graph or this kind of shading, you want to indicate your test point. So make sure you indicate your test point. Of course, you know how to graph a line from previous algebra courses. Let's do another linear inequality. Once again, you want to write down the associated line. This one has ax plus by is equal to c. The associated line that you want to graph is negative x plus 4y is equal to 8. So we're going to graph this straight line. Now this time it's a dotted line. How do you know it's a dotted line? You don't have an equal symbol underneath that greater symbol. It's strictly greater. Over here, this was what? This one here was solid line. This time we have a dotted line because of that symbol there. Easily graphed with the intercept method here. So if you use the intercept method, I can go ahead and give you the intercept method as ordered pairs as well. So when y is 0, we get x to be the opposite of 8. So 1, 2, 3, 4, 5, 6, 7, 8, opposite of 8. Plot a point here. When x is 0, we get y to be 2. When x is 0, we get y to be 2. And we could plot a point at 0, 2. And of course, if you have a straight edge, take advantage of it and plot a straight line. So you not only draw a straight line, you're going to draw a dotted line with the arrows at the end. Make sure you draw the arrows because you do need to match the domain and range of that linear function. Once again, we're going to test the original inequality, and then we're going to pick a test point to make sure we shade the correct side. We either are going to shade above the dotted line or below the dotted line. A convenient test point would be 0, 0. So why don't we test 0, 0, negative 0 plus 4 times 0 is greater than 8. True or false? Well, that's bogus. 0 is definitely not greater than 8. So this time, we do not shade the false side. In other words, we are going to shade the true side is actually above the line. We cannot shade the 0, 0 side. Now keep in mind you are just going to shade above the line. This time, because the line is dotted, we don't shade the line at all. In other words, that y-intercept is not a solution. And you're done. Once again, make sure you indicate the test point you are going to use. It's nice to graph and label all your ordered pairs as well. If you want to make it clear, you can go back and label your ordered pairs like 0, 1, and then what, 3, 0. Over here, this was negative 8, 0, and then this one was 0, 2. Always nice to label things very, very neat. Let's graph the inequality. These are actually quadratic inequalities, and so we are going to need to have a graphing form of a parabola. We're going to use this one. Y equals a times x minus h quantity squared plus k, where we know the vertex. The vertex is actually hk. So why don't we take this and put an equal sign for now. That way we know we're going to graph a parabola. It's actually going to be a dotted parabola. And we can see that little a is negative 2. I'm going to factor this out. And we have x minus 0 quantity squared plus 2. So we know our vertex. Our vertex is 0, 2. We also know that this parabola is opening down because there's a negative symbol in front of that 2 there. Let me point to it. This negative symbol here. And so this is actually going to indicate that this parabola is going to point downward, and you're going to have a maximum that is symbolized by the y value of the vertex. Why don't we graph this parabola? Usually 3 ordered pairs is darn good. So we're going to have 0, 2. Why don't we pick 1? When x is 1, we get y to be 0. When x is negative 1, you can also see that y is going to be 0. Remember, this is going to be a dotted parabola. Draw your axes. Zero, 2, right here, and then 1, and a -1 and 1. I'm going to draw a dotted parabola like that. So the parabola actually separates the Cartesian plane into two regions. There's a region inside the parabola, and there's a region outside the parabola. So look at this region here. There's a region inside the parabola, and there's a region on the outside of the parabola. So we just need to pick a test point that is not on the actual dotted parabola. We already know that's going to be false anyway. That's why it's dotted. So why don't we pick the origin? Why don't we test 0, 0 for the original inequality? Where is the original inequality? It's up here. Triple star. I'm going to go back to that triple star and we're going to test 0, 0. Go back and test the original inequality and see if it gives you a true or false statement. We're going to test 0, 0. So it's 0 greater than -2 times 0 squared plus 2. And the answer is false. This is a false inequality. It's basically saying, is 0 greater than 2? And that is not true. So that's false. So we don't shade the 0, 0 side. In fact, we're going to shade away from that 0, 0 side. We're going to shade this way. And make sure you do not shade the dotted line. Keep it dotted. So the solution to this parabolic inequality is that. What should you show? You should actually show your test points, and you should probably show your ordered pair. That's pretty darn good. Another key step is actually getting this in its graphing form. That always helps. Graphing form is right there. Why don't we look at the second example as well? Let's clear the board really quick. Let's clear the board. So we are going to look at part B. It says x squared plus y is greater than -4. Once again, you're trying to get that into a graphing form of a parabola. Why don't we move that? Let's move this over here. Doop. We need a graphing form of this parabola. So hypothetically, let's just put an equal sign for now. And why don't we solve this for y? You're trying to graph this parabola. And once again, we're going to get this in a graphing form, -x minus 0, quantity squared, minus 4. So you can see the vertex. The vertex is 0, -4. Make sure you get 3 ordered pairs. Why don't we pick, well, we're going to go ahead and graph from here. So I'm trying to get my ordered pairs from this equation here. It's probably easier. Let's pick x to be, let's just say 1 and -1. So -1 here, the quantity -1 squared is +1. Take its opposite and then subtract 4. So we get -5. And if you put 1, you also get -5. We have enough ordered pairs now. Draw a set of axes. Do the best you can. 0, -4, 1 and -5, -1 and -5. And we need a dotted parabola like that, right? Once again, there are two regions. There's a region inside that parabola, and there's a region outside that parabola. For convenience, pick a test point. Let's test what? Test the original inequality, x squared plus y. Well, we're going to test 0, 0 in what? X squared plus y greater than negative 4. Is 0 plus 0 greater than negative 4? And the answer is yes, that is true. So we got to shade 0, 0. So how do we shade 0, 0? We're going to shade this way. 0, 0 is on the outside of this parabola. That's the only way we could shade 0, 0. We shade. Shade, 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 shade. And that's good enough. Circle the work that's necessary. Definitely your graph. How about we circle all this right here? Show a test point, and of course, plot a accurate graph. Graph the solution to the following system of inequalities. Y is greater than negative x plus 1, and y plus x squared is less than 5. Let's do part A. We're going to try to satisfy this system of inequalities with shading, right? Inequalities is about shading. Inequalities is about shading the true region. We do have two of these. First thing we want to do is draw your axes. And in your own way here, make sure you could graph these equations correctly. So this one here, I want to graph y equals negative x squared plus 5. I'm going to pick on the parabola first. They're both going to be dotted. So I got to go 5 units up. There's 5. Maybe I should color that in black. And what else do we have there? So we're going to have a parabola like this, like that, and like that. Okay, another mark here. So I could quickly graph the parabola. It's going to be a dotted line. It's opening down. There's a region there. Now we got to graph the straight line. Y equals negative x plus 1. So we start with the y-intercept. Start with the y-intercept. And then we go down 1, right 1. And then draw a straight line through here. It's also dotted. So there are a lot of regions here. Let's look at this carefully. We need to pick, well, there's an intersection here. And there are a lot of regions. There's a region over here. There's one. There's a region out here. There's another region. There's a region on this side. And there's a region even over here. Now, let's see. What we're going to do is test the original inequality for both of them. Now, a convenient point to test is the origin, 0, 0, because the origin is not on either graph. So let's start with this one. Is 0 greater than 0 plus 1? And that is false. So I tested the line, and I got to shade the true side. So I got to shade this way, and this way, according to that statement. Let's test the other one. We're also going to test 0, 0, but we're going to test it in the other inequality. Is 0 plus 0 less than 5? And then this one is true. So this one involves the parabola. For the parabola, I do shade the 0, 0 side. So for the parabola, I'm going to shade this way, and this way. So where do these two arrows overlap? Where do we actually intersect all the shading? And the answer is right here. We got some blue, and we also happen to have some green. So that is the solution to this particular system of equations. What should you show for your work? You should definitely show your test points. You want to be able to graph those equations quickly. So you want to show that. Let's do another example just to get some variety. Let's go to part B. Take my handy dandy eraser. Ooh. Squeak, 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 squeak. Let's move part B to be a little bit friendlier on the left here. All right, part B. That first equation is a nonlinear equation. Well, it's actually an inequality. I need to make sure I write the equation associated with it. It's actually that. And that is actually the standard form, or it's in the standard form of a circle. This is x minus h quantity squared plus y minus k quantity squared is equal to r squared. So this is a circle with radius r greater than 0. And we also know the center. The center is hk. In our case, you can totally see that it's x minus 0 quantity squared plus y minus 0 quantity squared is equal to 9. First thing you want to do is graph that dotted circle. How do you graph a dotted circle centered at 0, 0? The center is the origin, but the radius, you already know the radius, r is 3. So you actually know 4 ordered pairs. You got 3 here, negative 3 here, 3 here, and negative 3 here. And then we simply connect the dots. Why don't we draw that circle? It's a dotted circle. There's no equal sign on the inequality, so it's dotted. Now we got to graph the parabola. The parabola says it's an opening down parabola, and there is a y-intercept at 0, 1. And when x is 0, y is 1. When x is 1, we get 0. So it actually goes like this. There's a parabola going like that. Once again, we have many regions. We have a region inside and outside the parabola, and we have a region inside the circle and outside the circle. Let's test both inequalities. Once again, we could pick 0, 0 for convenience. X squared plus y squared is less than 9. Is 0 squared plus 0 squared less than 9? The answer is yes, it is true. So you need to shade inside the circle, like that. Let's test the other graph, or the other inequality. The other original inequality is this. Is 0 less than 0 plus 1? And that is true. So we're shading the 0, 0 side for that as well. So we have the shade inside the parabola like this. So once again, where do the two kinds of arrows collide? Well, they're colliding here, and they're colliding here. And that's it. You only want to draw the intersection, or where both ordered pairs are satisfied in the true region. That's it. Let's circle our final answer. Circle your test value. You do want to show probably this, right? Standard form of a circle.